Hello everyone, good morning and welcome to TCBU Magazine interactive session on Futuristic HVAC Technologies for Public Spaces. India is a bright spot for heating, ventilation and air conditioning industry. Increasing urbanization and growth in the commercial, industrial and residential infrastructure investments are driving the demand for HVAC industry in the country. According to industry estimate, the Indian HVAC market size is expected to grow to 31,598 million US dollar by 2030 from 8,526 million US dollar in 2019 at a CAGR of 16% in the next 10 years. HVAC systems are an important part of any building, such as residential like homes, apartments, commercial buildings like hospitals, hotels, schools, universities, office buildings, and industrial buildings such as factories, warehouses, manufacturing plants, etc. So in next 1.5 hours, you are going to witness an engaging interactive session on futuristic HVAC technologies for public spaces. Our esteemed panelists will talk about next generation HVAC technologies for public spaces. They will also reveal their HVAC system design strategies for better comfort and energy efficiency in a public building space. Ladies and gentlemen, it's an honor and privilege for me to introduce you to today's distinguished speakers. To start with, Ms. Mala Singh of PEC Greening India. Welcome, ma'am. Mr. Vikram Murthy of Univac Environment Systems. Mr. Gaurav Vasudev of Gaps Engineering and Consultancy will be joining us shortly. And Mr. Dipu Manuel of Mitsubishi Electric India. So delegates, sit back and get ready to witness a thought-provoking session on futuristic HVAC technologies for public spaces. To take the session forward, I would like to invite Mr. Vikram Murthy. BTech in Electrical Engineering from IIT Kanpur, Mr. Murthy has experience of over 45 years in the HVAC industry. He is the director at Mumbai-based Univac Environment Systems Private Limited for unitary and applied HVAC products and systems. He is the immediate past president of the Indian Society of Heating, Refrigeration and Air Conditioning Engineers, that is ISHRAE, and past president at the American Society of Heating, Refrigerating and Air Conditioning Engineers, that is ISHRAE, Mumbai chapter. So to get the ball rolling, we will invite Mr. Murthy to talk on next generation HVAC technologies for public spaces. Welcome, Mr. Murthy.
Thank you, Subhajit. So I'll begin. So today we are going to speak about innovative HVAC for public spaces. And I'm very happy to be here on this panel because there are good panelists. So that's one of the main reasons. Also, it's organized by a publication, Thermal Control Business Update. And I have been going through their updates and their magazine for some time now. And I really am very happy to see that the vast amount of information which they put forward. And I encourage all of you to do so in the time to come. But let me get on with the topic of the day. So we are going to focus, as I imagine, on public spaces. So I like to define what is a public space by going to my next slide. So as you can get to see this slide and take your time looking at it, I want to define, in my opinion, what is a public space. So a public space is a place where communities who reside in cities or in larger towns and so on can go to gather for some work or for some interaction or for some purpose. They are not commercial buildings where people come to work and others come to visit them. They are certainly not, shall we say, residences and larger spaces like that, which might be large. They can be schools, they can be hospitals, they can be airports, they can be railway stations, they can be museums and things like that. But I would like to exclude malls from my definition of public spaces, although we can include them, because malls restrict the entry of ordinary people into them merely because of the high level of cost for affording a mall. But if you're visiting a mall just to roam around and all, malls also can be called a public space. So the whole idea of a public space is that it should welcome people of the city. Cities of the world are defined by the beauty, grandeur, comfort, and multitude of their public spaces, like the city of Delhi, to a lesser extent the city of Mumbai. And there are many cities in the world which you know, which have beautiful public spaces. So here's a picture of a church which has been disused and converted to a nice library. But the beauty of it is it's allowing light from a very high level. Its height is very high. It's very comfortable. Of course, it's in a country which is not very hot. But nevertheless, the use of the space has been done so beautifully. It's a public space. And reuse of old buildings into nice public spaces is a wonderful way to expand our our stock of public spaces. So this is a museum in China. I have not been to this place called Ningbo, but I have been to Shanghai, where there's similar smaller museum I visited. The beauty is it's constructed of local earth materials like bricks, which we have in India. And it doesn't have many windows because it's a museum. There's no need of bringing the whole light inside. And it's so thick, the walls, that it never gets hot inside. The heat can never enter the building, so its load is very low. And it has lighting, which is, of course, LED lighting and so on and so forth. So it's a very cool building. And it's a very nice building for the purpose it serves. This is a building which is showing you the advantage of shading. It's a very huge spread of something like a canvas, but it's not made of canvas. And so it gives such wonderful shade to this modern looking museum. So it cuts out the solar heat by a huge percentage. So public buildings must take advantage of nature to reduce their cooling load. This is my point. So this is a building in my own home in Mumbai. And it's a beautiful building designed by Skidmore, Owings and Merrill, which is a very large architecture firm in Chicago, over 100 years old. But see the beauty of the building. It's one of the 100, shall we say, most desired buildings of the world. I have a little book on that, my TED Talks. And see the building, how nicely it admits light and how easily this cupola shaped ceiling is constructed. And it's got very strong ceiling. You don't need beams in a ceiling construction like this. You can go on and on and on and on and on and on, right from here to there, which is maybe half a kilometer long. And it has got lovely lighting aspects. It has got cooling from very low level. So you don't have to cool the whole space, which I shall talk about later. This is a space I visited. It's in New York. It's a museum, a botanical museum. But see how the beauty of using nature into the building and having a very cool roof. And it goes down, snaking out over there. There's an open area. There's a closed area. There are 3 basements below. Basements are very cool. So this is a building which also I visited in Seattle. Seattle is not a very hot city, but this library is made of glass of different U values on different sides, depending on the sun orientation. This side, you can see such beautiful shade is there, so people can be outside. So these are just examples of public buildings. This is a newer building, which I visited last year in Washington. So this is the Museum of African American History. This is supposed to look like the crown of an African king, but it is so well designed to admit light, to reflect heat, and it has got water bodies next to it. It has got 3 basements below. It admits light into the basements naturally. So public buildings are beautiful. This is a concept in New York. They have a railway line going right through the city, which is disused. Above this line, they have converted to beautiful open walking space. And now they want to convert the space below it. It's like a large flyover kind of thing, but it goes on and on for miles. So it gives a huge amount of shade. And you can convert this whole into a lovely walking area, shops, museums, whatever you want. And some of the stations are below ground. You can convert them into spaces. This is in Delhi. This Bahaya temple is really beautiful in this lotus form because it admits air at different levels. It releases hot air from the top. It admits lights all over the place. And it's got water bodies all around it. This is our own, shall we say, General Post Office in Bombay near VT. It is so cool and wonderful inside. There is no air conditioning. It's the grandeur of height and also the quality of stone, which doesn't allow heat to come inside. So it's always very comfortable. I've spent hours over there looking at stamps and all many years ago. This is our own crowded Victoria Terminus station in Bombay. It's not so crowded now for a reason that you know well, but it gives a wonderful feeling of comfort inside because of its construction. So what is the problem with the whole world today is that we are getting hotter and we are getting more humid because the wet bulb is also rising. That's a big problem. So in Mumbai today, it is quite warm. It is quite humid. So we have to do air conditioning. That's the general idea. So our body gets comfortable with temperature, with the radiant surfaces around us. If they are cool, we will lose heat faster. Of course, the humidity and most of all the air motion. More of this, I think Gaurav will speak about. But here's what I want to say. We must slowly ratchet up higher and higher our indoor design conditions. Every degree centigrade you take up, you will save 3% energy. If you go up from 24, or let's say 22 to 30, you will save 25% energy. So here's what we've recommended in ISHRAE. It's approved by many bodies today. And we can say you can go up to 70% humidity, depending which part of the India you're in. And you'll see more about that later. So raise the temperature in public buildings. I'm speaking a little bit quickly for the sake of time. So I will not spend much more time on this, but this is in the old days. Palaces and all were cooled by water bodies which came right around the palace. And these are fountains. Because of gravity, the fountain will start working. And by evaporation, the whole palace gets beautifully cool. The Taj Mahal has a different principle. It is the body of thermal storage. It has a huge base. It's gigantic and stone. It goes deep into the Yamuna River. And because Agra near Delhi has very hot and dry summers, but very cool winters, all through the winter months, the stone gets cool and it gives off cooling in the whole of summer. And during the hot summer's day, this whole stone gives off its heat to the water. It's so well designed. And it's got the idea of thermal storage, which we are using today for large buildings. This is a institution I studied in. It's IIT Kanpur. One of the one of the delegates over here, Arup Mazumdar, also studied here, but he's much younger than me. But when I studied there many years ago, we had this whole central cooling system. It's still there, but it's in a different form. It was 1,000 tons of air conditioning centrally. In the 60s, it was installed. And it cooled all our buildings. It cooled the library, it cooled the laboratories, it cooled the lecture halls. And this library, instead of a cooling tower, had a fountain. And this fountain beautifully gave a microclimate around the library. And you would have otherwise had 3,000 tons, but we ended up only with 1,000 tons. So here is the map of India. What I want to tell you about India is, India has a beautiful coastline. So if you live along the coastline, the conditions are not so hot. But if you live over here, they are very hot and dry and extremely hot in these areas. So we must take advantage of climate to design our air conditioning system. However, there's something to note. We are the 7th biggest country in the world of about 3 million square kilometers, whereas America and China are the 9 million, 3 times our size. However, we generate the 3rd highest power in the world. I'll come to the next slide. 1,500 terawatts of power, for 1/3 the size of China. Of course, China is 3 times the size of us, but it generates much more energy. So we must be mindful that we are the 3rd highest generator of energy in the world. So we are a big guy responsible for global warming just because of this reason. And 70% of our energy generated is from coal and oil and all sorts of things like that. So here's what you see. We generated a year back 1,600 terawatts of electricity, which is 1 quadrillion watts. It's a huge amount of energy. You can't imagine how big that is. My city of Bombay consumes about 4,000 megawatts of power. And so that's quite big as it is. But we are talking of something as big as this. In that, the cooling energy consumed was 135, which is about 8 to 9% of all the electricity in India was consumed by cooling energy. If we go 20 years from now or 18 years from now, it's going to become 600 terawatts of cooling projected by the India Cooling Action Plan. And if the energy doesn't increase, then we will be, how much of that is this? 1/3 of all the energy will be used up by cooling energy. Of course, this will also go up, but we cannot go up in energy. That's the whole problem. We don't have any more energy left in India to produce. We can produce it. Nobody is stopping you, but Mr. Modi has promised that global warming will come down. We will reduce global warming by 30% in another 10 years. So we have to do it. And therefore, we must have other means of cooling public spaces, which is what I'm going to talk about. This is the whole point. Electricity too high, energy too high for air conditioning. So we can't afford to use it anymore. So we must wonder what to do. So indirect evaporative cooling is a very nice way. It has already replaced 100,000 tons of air conditioning in the last 10 years. It is 2 stages of cooling. First, you cool by water without contact, and then you cool by water by evaporation. This is a very conventional way of doing it. There are other ways too, but it is going and it is booming in all the central parts and dry parts of India. This will replace rapidly air conditioning for public spaces and even for places like malls in Indore and all. It's already going on in a big way. Structure cooling is a big thing. I'm advising the government of India for the Central Vista project as an advisor. So over there, we have strongly recommended that the new Parliament House, the whole outer structure should be cooled by pipes which are embedded, which evaporate water by natural processes. It must have a cool roof. It must suck out all the heat which goes into the building before it goes in. So that's a big way of helping to cool structurally public buildings. Radiant cooling is going to be a big future, like that museum which you saw in China, which I showed you. If all the walls were cool, there would be no need of any air conditioning system because there are only people load inside. There is no outside load of heat. So the people will lose their heat by radiation, which I'm showing you in the next picture. Very simply to the walls, to the roof. This lady is in a gym. So this is a very small scale version of that. So you have pipes buried and you pump in water at 12, 14, 15, 16 degrees centigrade, much higher than air conditioning. And you have another small system to pump in air at cooler air to remove the humidity. So you divide the whole air conditioning load and you're able to afford a high temperature for the sensible cooling, which is 80% of the load. The other thing is start pumping air from low levels instead of cooling the whole space. Most times we are cooling the whole space and wasting all the energy. There is nobody over here. Everybody is 6 feet off the ground. So all the airports of India today are cooling by displacement ventilation. And I don't want to discuss more because it will take time. Also, we have these new things coming up, this wraparound coil. Without any energy, it sucks out the energy from the hot air in heat pipes which have refrigerant. Those become hot and come the other side. But in the meanwhile, the air is already cooled and it gets cooled by the cooling coil to a much lower temperature, more dehumidification. And then because it's got 100% saturation, you dry it up and pump it in and you get so much more, 20% suck out free cooling from the air handling unit. It is also explained in the hybrid form here, where we are allowing 40% of the return air to cool the inlet air in a heat exchanger. And we use all that energy to cool the air sensibly and then put a cooling coil. And this is what is happening in Hyderabad, many places of India, wherever it's dry. And so they're able to solve the COVID problem. 40, 50% of outside air for free coming inside and cooling you. What better do you want? Underflow air conditioning will be a big thing in public spaces. And this divide the whole system into chill beams, which don't require air pumping. They're very quiet. You can use them in museums. You can use them in airports. And then you have the other system, which is for the fresh air and pump it out. Here is one thing I want to talk about for just a minute. Let me see how much time I've taken. So I shall try to finish quickly. So we have this wonderful invention from a company in India, which is called the Absorption Chiller. All it needs is 36 degrees water as the energy source, and it gives out chill water at 7 degrees. The principle I will not go into now, but it's the principle of desiccant. It's also the principle of adsorption, and by vacuum systems are moving. No compressor, no motor, nothing. It just needs hot water, which you can easily produce by solar energy. So easy to produce it. It's available from 30 tons to 3,000 tons. Already there are installations in India, and this is going to be the biggest boon for us for public buildings in the future. It's slightly costlier, but it will pay back very soon because there is no energy required. And you can produce energy the whole day, and you can store it and do it later. So I just come to this one building. It's quite an old building in Delhi. I visit here very often. Gaurav also comes here, who's on the panel. So this building was designed by an iconic architect, Joseph Allen Stein. Stein, Doshi, Bhalla were great architects. So this building is beautifully landscaped. It is surrounded by the green cover of central Delhi. So it remains cool. There's so much of grass on the ground, so the ground doesn't get heated up. It has got pergolas, it has got sun breakers. And so the air conditioning load is very minimal in all these lecture halls. It uses natural brick, which doesn't allow heat to come in. It uses, shafts like this to remove the heat by normal rise of ventilation air. So here's the building. You can see all those sunscreens. So I just want to end with one thing, that all these places of public buildings and so on and so forth, which I've talked about, they can be air conditioned in many ways. I've just talked about a few, and I can talk about more later. But the point is that only 10 or 12% of India is enjoying air conditioning. This is the sad story. So you must all think about it. And if you walk through any parts of North India, you find people on cycles hauling goods, and they are constructing buildings of towers of glass and steel for you, for the 10-20% of India. And very few of us are protected by air conditioning. Those who can afford it are in comfort. Those who can are becoming worse. And because the wet bulb is rising, this is the biggest wonder of India. Not wonder, it's the danger. That the wet bulb in Delhi has gone up to 28, it may go up to 29, your body is at 37. When it goes past 30, 31, which it might happen in 10 years from now, then you will never be able to lose heat from your body when you're outside, and in 6 hours you will die. So how will this lady work then in the hot place? Which is why we need more and more thermal comfort for all. And the only answer is to have public buildings which are able for the ordinary person to go and relax and study and be comfortable. So we must all work hard for that. There is no challenge which we as designers, architects cannot do. So I urge all of you to join your hands and think about it, that public buildings is the answer to India, because commercial buildings are emptying out fast and people are working from home.
Now in this session of TCBU Magazine interactive session on futuristic HVAC technologies for public spaces, I would like to invite Mr. Dipu Manuel to take the discussion forward. Mr. Dipu is currently designated as Product Head Variable Refrigerant Flow, that's VRF, Living Environment Division at Mitsubishi Electric India. He is responsible for managing product training, new product development, technical benchmarking, market analysis, team development, PSI management, and business planning. Today, Mr. Dipu will talk on the benefits of VRS systems in commercial buildings. So let's welcome Mr. Dipu.
So thank you, Mr. Roy, for a wonderful introduction, and thank you, Vikram sir, for taking us through various current and the future technologies on the public spaces. So I just limiting my presentation to the VRF systems. So greetings to all of you. So I just want to take everybody to an era before COVID-19 for a few minutes. So I want everyone to take a deep breath and think about the last movie you have seen in a movie theater. What do you remember other than the movie? Did you feel too cold or too warm, or it just comfortable? Now I want you to think about one more scenario of attending a meeting in any of the offices. Two conditions. First one, the meeting room is overcrowded with people standing and attending the meeting. And in scenario two, where it's a very big meeting room, but you and only one more person are there. What you feel? You feel too cold, too warm, or just comfortable? The point is, the air conditioning requirement on a commercial building keep changing every minute, and the biggest challenge for an aircon system is to keep on adjusting to these fast changing requirements very fast and precisely. In older days, the system used to have a temperature sensors installed on one location, mostly near the return air path, near the air handling units, and the aircon system tried to adjust the temperature closely to the set temperature of the users. But this system has one of the disadvantages, as the location of the temperature measurement is not where the people are sitting. The time difference between the measurement of temperature and adjusting by the system to that temperature, it takes much longer time, leading to people become uncomfortable with overcooling or low cooling, use more sensors to collect precise information and make the aircon system to respond to the feedback data very fast. And the second one is to make the aircon system personal. Even in commercial building, wherever possible, try to make it a smaller systems. The current pandemic of COVID-19 has given a feeling to people that the virus is spreading through centralized aircon systems. Before checking the truth, people want to design the systems with small airtight zones to contain the spread of viruses. An after effect of more compartmentalized aircon design actually is going to help people to set their own temperature in a commercial buildings, which is suiting to individual users. Maybe a blessing in disguise. So how can we make the commercial buildings with varying loads and different temperature settings of aircon practically possible? One of the answer is VRF systems. VRF systems are variable refrigerant flow systems which can be connected with different type of indoor units, and each indoor unit can maintain different temperatures based on the user's feedback, user settings. So what is the future of VRF systems? I think the current VRF system itself is much advanced. I like to emphasize on some of the technologies which are available in VRF systems but not widely used by customers in commercial building designs. VRF systems have its own occupancy sensors which can check on the actual number of humans present in an area. VRF systems have infrared sensors to measure the temperature inside the room and guide the aircon flow to the hot pockets and can adjust the aircon accordingly. VRF systems got various sensors which will precisely help to adjust capacity of the aircon fast enough to make the user comfortable. VRF systems can be integrated with various sensors to control the fresh air flow, exhaust air, and also to maintain the indoor air quality the way which is comfortable to the human beings. VRF systems can take lesser space and don't need an operators to maintain. Because COVID-19 calls for less number of people coming together. So one can less in a public area or a commercialized building, you can have more productive people employed. It's a more and safe system because it's more factory assembled and do installations at the site than combining many of the systems. So when the moving parts of a system can be independently controlled based on the feedback data, we have a very smart systems. But when we add analysis to the feedback data to control the output of a system on a real-time basis, we have an intelligent systems. VRF systems with lot of feedback and lot of sensors which collect the data, and with a faster response to the data collected by these sensors, we have a future-ready systems which can keep adjusting to the need of the users. By changing the logic to a software update, we can change the functioning of an existing electromechanical parts of the VRF system to deliver better comfort with a better efficiency. So VRF system is one of the future systems of aircon for the commercial buildings. VRF gives better comfort, better energy efficiency, smaller footprint, no need to have a dedicated trained operators for daily operations, and it's a future ready systems. So let us design a smart and better aircon system for commercial buildings using VRF systems. As Vikram sir also explained, we need more daylight, we need more fresh air, we need it to be a thermally comfortable building with adequate ventilations, but not spending a huge amount of energy for achieving all these points. And social distancing is a norm, that is a new normal, which is going to be there, which is going to impact on the design in the future, which we feel more individualized, airtight, compartmentalized zones may be one of the solutions to contain the virus spreads, but still keep the people productive. So let us decentralize the system.
Ladies and gentlemen, as you are aware, breathing quality indoor air is critical for good health. Thus, maintaining indoor air quality at public utilities places is quite important. Today we have Mr. Gaurav Vasudev with us to discuss the role of HVAC systems in maintaining indoor air quality in public spaces. Mr. Gaurav is the Managing Director of GAPS Engineering Consultancy, a company specializing in engineering services for computational fluid dynamics, that's CFD for HVAC, and other fluid dynamics related services. He is also the past president of Delhi chapter of ISHRAE. So welcome, Mr. Gaurav.
Something very important when we are cooling the spaces in. In private buildings or commercial buildings or houses or offices, we can have a control on people getting into it. We can check their temperatures, we can check their health, and we can actually stop them entering those places. But this is not going to happen in the private places. And the public places is going to be very tricky. We don't know which kind of people who are infected, non-infected, they are entering into that public space, and they are exhaling out there. So virus or contamination they are releasing inside, which is going back to our HVAC system. So that is going to bring those viruses to multiple locations, to multiple people, and that is going to have more problem for us. So moment we get into thermal comfort, we improve our temperatures, we somewhere has to look into adding more fresher into system. So the purpose of improving indoor air quality is, of course, to reduce the carbon dioxide, which is actually hampering our mind, our body, and our physiological stuff overall. And the moment we need to work on carbon dioxide, we need to add more fresher, and the fresher need to be cleaned enough. For that, we need to look into a kind of futuristic filtration medias, filtration technologies, which will not add up too much load on our air conditioning system. There are a lot of options available in the market. There are a lot of technologies, upcoming technologies, which is going to work on this kind of futuristic filtration medias, products, which can help into improving on PM 2.5 level, which is hurting our lungs and all that. The second major object in recirculation air comes to the virus. Even we use a VRF system, ducted VRF, or we go with the centralized air conditioning system, or we go with any other recirculation air conditioning system. The second major thing which comes into place is our bacteria and viruses, which we don't want that to travel back to system again and get into lungs of other people. So for that also we need to look at some kind of technologies which ISHRAE has been also speaking about. ISHRAE has been always speaking about that we need to go with a kind of a UVGA system. UVGA system inside the air handling unit or a ducted unit, and more specifically to the ducts, which is the media which takes the cool air from air handling unit and deliver it back to the space where the public is moving. We need to make a kind of UVGA system in the ducting which can take care of the viruses inside that particular travel medium altogether. Then secondly, when we are talking about the ducting, it is the most place which has not been attended by any HVAC engineer that frequently. This COVID has made a point where people are now started looking at indoor air quality. They started looking at how better indoor environment they can produce, and with that you are started getting into looking into your ducting. Ducting need to be clean enough regularly so that you don't have any contamination lying inside. The leaking should not be there in ducting, which attracts a lot of dust from outside. So there are a kind of coating which is available today in market which can be done inside the ducting. One that reduces the the leakages into the system. Second, it is helping up in terms of creating an antimicrobial, antibacterial surface which will not let the kind of bacteria, microbes regrow in that area or in that ducting, so that our ducts are remain clean for a longer time. So this is the kind of technology we need to implement into our existing systems, because these technologies does not need any kind of a new project only. It can be done on the retrofit side as well, because as we are going to open our air conditioning system in our cinemas, we are going to open our schools, we are going to open our universities, we are opening up our malls. There these kind of technologies need to be put in as on today, so that not only the new project which is going to come up have these technologies implemented, our retrofit, our old projects also get these futuristic technologies to make life better in the public spaces today as well. So indoor air quality, we all need to look into it very seriously from a point of view that we can help our lungs breathe good and have better oxygen inside.
Ms. Mala Singh is an alumnus of IIT Roorkee as an environmental scientist. Today, she is a prominent green entrepreneur in India with more than 20 years of experience. She is a certified IGBC fellow, IGBC AP, and lead green associate. She was recognized as one of the top 50 green leaders globally in the World CSR Congress 2017 and bestowed with the title of IGBC Fellow for her outstanding contribution to the green building movement in India in 2016. Today, she will enlighten us on the green building certification and HVAC. So welcome, Ms. Malashing.
Coming to because today's session topic is very specific to HVAC technologies. Let me tell you, green building has some basic requirements in terms of design of HVAC, in terms of your practices which you do during construction to basically look after your indoor environmental quality as well as the post occupancy. So very, very important aspects is one is your energy efficiency and your IQ, indoor environmental quality. So let me tell you, when in a green building as a green auditor, when we look into any project, maybe it is a new project or it is a existing project, but always, in existing, I think previous speaker said that it is a little challenging in the existing project to retrofit the, technology. But in the new project, still it is doable and easy to integrate in the design itself. So in a new project, because when it is a green building or non-green building, I would say in any public space, system need to be designed, with the thought process of keeping in the mind how you can reduce the energy consumption and also how you can improvise the indoor environmental quality. And also side by side, how you can maintain the thermal comfort. Because these three things are very, very important when we talk about green and non-green together in respect of HVAC technology. And I think one of my speaker, initially the first speaker, Mr. Murthy, has beautifully shown some presentations and some buildings, which itself talks about, a lot of passive technologies and passive strategies. And very, very, I think he explained in respect to Indian environment also. And if you see our ancient, buildings, and they had already used those kind of passive strategies to improve their, I would say, to keep their spaces cool by thermal mass or by designing their building envelope in such a way so that, you can minimize the heat gain and you can also increase the, I would say, indoor environmental quality. He also talked about cool roof. He also talked about evaporative cooling. I think he mentioned all the technologies which I was going to talk today. So all in his presentation, I just saw everything is already covered in that. But definitely, I feel very happy. Mr. Murthy, all those technologies in somewhere I'm using in my most of the projects. I would not say the name, but definitely I'm using radiant technology in one of my commercial projects. We are also using distinct chiller, cooling technology for various, I would say, larger master plans of medical and healthcare facilities. We are already doing that. And you also talked about evaporative cooling. Definitely, that is also integral part of my lot of projects. So I'm already getting benefit and I have already got the benefits in terms of energy efficiency and in terms of improving the air quality. And I think I will not talk too much about because these are very common. All the experts are sitting here. They know what is ISHRAE, what is applicable to energy efficiency, what is applicable to IEQs applicable. But in green building, let me tell you, there are 3 certification, very prominent standards in our country. One is the Indian Green Building Council. Other is your LEED, which is governed by USGBC and GBCI, and then GRIHA. These are 3 prominent. There are some few more, but these are 3 are very, very prominent certification bodies, which talks about building envelope and optimization of building envelope by designing, energy efficient HVAC system, where we are giving consideration to ISHRAE standard, ISHRAE 62.1 in energy efficiency, and also we are giving consideration to ISHRAE basically 62.1 for fresh air intake, and also looking into the thermal comfort ISHRAE 55, and also we are looking into the National Building Code 2016. So these 4 standards are integral part of our green building design in the planning itself. So whenever we look into any building, in respect to its design and HVAC design, we consider all these standard requirements with respect to the technology intervention. So we never say go ahead with any, I would say BOQ vetting unless I'm not comfortable whether my minimum requirements to meet these standards are met or not. That's very, very important when in a green building aspect. But I think Mr. Murthy also rightly said that India is the 3rd producer of, the energy in the world, which is a very, very, I would say, warning also to us. But also he explained that in 10 years, the demand is going to very high. It's almost, I think, 6 times, he said that. So now it's a green building and using these standards efficiently, keeping in the design in the mind, and also the operation, not only the design. Let me tell you, in most of the building which I have observed, we have installed all the equipments of HVAC design and technologies with respect to standards. But what happened? As I think one of the speaker also said that they are not being maintained properly. Operation and maintenance is very, very important component. So here it is a very important to look into the, facility management role, which comes into the picture. I think we generally ignore that because that's very, very important. Unless you don't maintain your HVAC systems efficiently, they cannot perform as per the design intent. Because whenever we are designing, we are looking into their performance factor that we choose the technology. But when they come into the operation, they are working as per the design intent. That is also very, very important. So how you are setting your schedule, how the building's actual occupancy is there as per the design intent. Because I have seen in my personal experience that building are designing, for some different occupancy, for some different area configuration, and you design the HVAC system like that. But after that, when you do testing and verification, post occupancy, you feel that it is not performing as per the design intent. So that's what it is very important to measure and monitor each and every aspect, which tells us that what kind of quality of air I'm breathing into and my thermal comfort. I think this, I would say this can be solved with the integration of all technologies and connecting it with the proper integrated building management system when it comes to the commercial or public spaces. Because in some of my projects, I have seen that all systems are very, very, highly configured with very smart and advanced technology. But when we do the audit, when we realize that energy consumption is still very high and air quality is so bad, because this is just because of inefficient operation. And in most of the commercial building, they don't have BMS. They don't have building management system. So automation is also helping us for making our HVAC technologies, in a very smart manner and in an efficient manner. That's very important. So designing, then during construction and post occupancy measurement and monitoring, then I think it makes a holistic approach. And at the end, we really get the advantage and we get the outcomes and results. What basically we are having in the mind when we are designing those HVAC systems. So that's very, very important. And doesn't matter the certification, you get a platinum rating, gold rating, or whatever. Finally, the result you get, how much you reduce energy consumption and how the people are happy in those buildings, the productivity is higher, your absenteeism is less, all those factors are very, very important. So basically, IAQ, when it comes to in the picture, so a lot of strategies are there to improve your, I would say, indoor environmental quality also. Even your small plants also play a very important role, not only the technology only. So sometimes, it is technology versus your behavior approach.
Mr. Murthy, being an industry veteran, would you like to talk on your HVAC system design strategies for better comfort and energy efficiency in a public building space?
So I will take from what my fellow panelists have already spoken about, and I will begin by what Mala Singh spoke about, is that first of all, when you do any building design for any building, and especially for a public space, we must know what is the utilization and then design that building systems. So following standards is a very good practice because standards give us a guidance about how to design, what to take care of, what are the minimum energy performance standards. So those standard applications she is doing in her work, and she is doing it means she has a system of doing it, which is a good system methodology which she has adopted. So I think following a system design methodology is one of the first principles. Secondly, we must be very mindful, since we're talking about HVAC, of which is the most suitable system to adopt over there. Today, Dipu spoke about VRF systems. VRF systems have their versatility and they certainly have applications in many public spaces, which include metro railway stations. The city of Chennai is doing all VRF systems for its metro station cooling. And even in Delhi, DMRC is adopting it for some of the stations, and in Hyderabad. So adaptability of a system is very important. Flexibility, part load, all these things that VRF system can do. But it's not the only system which can do that. The other thing about public spaces is to note very much that there's going to be huge variation in load. And I think the last thing, which I will just stress about, is simplicity of design. Because public spaces are going to be managed by simple people and government authorities or whoever that authority might be. The simplicity of design should be there unless it's a very complex airport. But even airports are struggling to maintain their facilities well. And lastly, what Mala Singh spoke about is to monitor and measure all the time. It's very easy now to get very cheap quality sensors of temperature, humidity, current and pressure, put hundreds of them in the building. And there are nice people, young people now who are making very cheap, what you call data loggers and presenters onto your phone. You can sit there and see how that building is operating as a manager. So these are the four aspects.
When any public space commercial building, let me tell you, HVAC design is a very, very important in the green building, as I told you. So in green building certification, unless there are some mandatory requirements, mandatory means prerequisites. So you don't meet those requirements, so your project is not qualified for certification. For example, I'll give you, let us say you are doing a certification for any project, public space project, unless until you don't meet the minimum fresh air requirements. So your project is not qualified, does not matter you have a very, high profile technology in terms of HVAC, whatever. Unless you don't meet the minimum fresh air requirement, your project is not qualified for green building criteria. And also there are some mandatory criteria like CO2 sensors, which Mr. Murthy has already spoken about, because unless we don't have CO2 sensors, and also its controlling and monitoring is also equally important. Not only just putting sensors and installing it, but also its controlling and monitoring, which also really, very, very important in the green building certification program. So apart from that, eco-friendly refrigerant and their refrigerant charge is also very important. Because, when we are talking about energy efficient or climate control technologies, we are also talking about least ODP, materials and technologies, where you have less ozone depletion potential. So we are looking into the refrigerant also, like what kind of refrigerant that particular HVAC system or air conditioning system is using. So we basically, I would say do a evaluation based on these criteria. There are some mandatory criteria and there are some criteria which gives you some additional credits and upgrade your rating. It's like that. And also in HVAC system, we also look into thermal comfort. So for that also, we are looking into the monitoring systems, rightly said by Mr. Murthy, that you can also check your relative humidity and temperature, and the design spaces, you have designed for specific occupancy, specific schedule is there. So like, every building has its own character. Every public space has its own character in terms of its operation also and in terms of its design also. So we look into green building, not only that, but during design also, climatology is also very important. Suppose you are designing your system, in which climate, so that is also very important to follow the standards and their building envelope strategies, passive strategies. So it's a very integrated and holistic approach when it comes to the green building. But definitely, let me give you an example. In existing building also, when we do retrofitting and we make it also as a green certified building, so in the retrofitting program also, we look into all those gaps and we fill those gaps by retrofitting, by introducing fresh air in the old buildings. We also, sometimes change their water cool chiller or, whatever retrofitting aspect it requires and improve the process entirely. So green building is helping us in a lot, I would say, in meeting the standards also, and I would say in operation and maintenance also, and building monitoring system also. So green building certification is really helping us a lot, because you are basically aware what to do, and how to perform. So because you are measuring each and every aspect from the design, during construction and post construction. This is what the beauty of green building, and you get the tangible and intangible benefits.
Mr. Gaurav, now Mr. Murthy spoke about the technologies, and Ms. Mala Singh spoke about the kind of standardization required or kind of collaboration required. Can you tell us that why it is necessary to collaborate within all stakeholders for a building to get desired indoor air quality?
Okay, so when we speak about indoor air technologies, something which is very important, we all need to understand. Today, we are spending 90% plus time inside. So whether it is our house or the school or our office or somewhere or else, we are spending our 90% of our time inside. Okay, we have a choice of looking into our food. We can pick up food what we want to eat. We have a choice to drink water. We can choose our water. But we are not able to choose the air what we want to breathe. We are forced to breathe whatever is just next to my nose. I cannot change it. If we are not looking into it very seriously from day one, this is going to be the contaminated thing which is going to go inside me. And the effect of this bad air or bad indoor air quality is going to affect on my health. It is going to affect on my productivity. It is going to affect definitely on my comfort as well. So even I have a good temperature, I have a good humidity, but my air is bad, then I am not in comfort. I am going to have headaches, which generally happen. You can visit some offices in afternoon, somewhere about 2:33 after post lunch session. Most of people are drowsy. They are either feeling kind of a sickness or some headaches, or they just want to go out and have some tea or coffee or something. Why? Because at that time your digestion process has started working, your carbon dioxide exhaling is gone up, and if you're not taking control on that, it is going to give you drowsiness. It's going to lose on productivity. There are a lot of studies happen in terms of looking at health point of view, productive point of view, and also on comfortable situations as well. And one of the productivity study done in Denmark in one of the universities, what they did, they made a class one where they were feeding a good number of fresh air quality, and another one was getting a contaminated or recirculated air. So what happens, they monitor the students while they were typing, how many minutes, how many words per minute they are typing, and you will amaze to see the guys who were sitting in a fresh air or a better air comfort, they were 10%, 11% more productive than those guys who were sitting in a recirculated air. So it's very important that we need to look into our indoor air quality. There are a lot of things available today, a lot of technology which can be retrofitted on our existing projects, which is very much easy, very much possible. Like a kind of a duct cleaning is possible. With duct cleaning, same process can do a duct coating inside, which can prevent your ducting from antimicrobial, antibacterial surfaces. UVGA system that can be very easily installed inside the existing air handling unit. It can be installed in the ducting, return ducting, to kill the viruses and other contaminated which is getting into recirculation. My fellow panelists have spoke about the CO2 sensors. How to integrate CO2 sensors. Every EHU, in a good design concept, even we talk about the green technologies as well, they try to bring more and more fresh air inside, so that I have to run my air conditioning chiller to the minimum level. So the moment I'm talking about my fresh air coming inside in early hours of morning or evening hours, it's not a problem. The moment the temperature goes up, we need to look into comfort, and we start our HVAC compressors and all that. The moment we do that, we need to close on our fresh air ducts or fresh air supply. The moment you shut down your fresh air supply, what is happening? You get the temperature, but CO2 is going up. The moment CO2 is going up, what will you do now? You again need to go back and open your fresh air system. So not only monitoring the CO2 level, that CO2 sensor which is helping in controlling opening and closing of our fresh air dampers, so that we are not losing on energy at one point, and we are also able to add good amount of fresh air inside based on the demand which we have inside the air conditioning area. And the moment another challenge comes in, the moment you start putting the fresh air in, you get a lot of contamination from outside. Let's say if I talk about Delhi, we have a lot of problem on PM 2.5, which generally happens from September and goes up to February these days. So we have a very heavy load of contamination of PM 2.5, which we don't want to let into our system again, because that is going to have a problem with our recirculation filters the moment heavy load of pollution coming in. So we need to have a proper filtration of our fresh air which is getting into system. That's also very, very important. The moment we are looking at a filtration, we need to look at energy saving as well. So we cannot put a HEPA filter on a filtration system or TFA or the treated pressure units also, because that will add a lot of pressure on the fan, and the moment you put a lot of pressure on the fan, you are going to consume more energy. So there are technologies available. It can be ESP, it can be other magnetic technologies are available today, which can help to reduce the pressure load on the air handling units as well. So monitoring CO2 and adding the pressure with the filter, that will definitely going to help us. Talking about UVGI, talking about the technology with kill virus, more important thing which Malaman has also identified the losses which we get into our technology today. Not only in India, it's happening in US as well. I have some counterparts sitting in US. They say that the leakages in the ducting in US is also up to 70% in some of the commercial places. So we really need to look into our ducting where we can seal them properly from inside, so that we don't lose energy. The moment we we'll save our that kind of leakages, we can really make our systems much more smaller in capacity altogether. In India, I've seen a lot of design in past has been like, if you need 10 ton, they have been designed for 15 or 16 or 18 ton. Just take care of all these leakages and losses inside the system. If we really take care of these small losses inside our inside our system, we can really go back to our original design of 10 or 11 ton for that kind of application. So if we start doing all this, we can definitely have a better healthy indoor environment. We have healthier people, more productive, and comfortably sitting and spending more time.
Actually, Mr. Gaurav, when he was speaking, I think he gave the same point already, which I wanted to say. Because in green building, there are two aspects which you had spoken about. One is the filter media. So generally, we prefer, the MERV 13 filter, for filtration media. And also UV lamp, that's also very important post-COVID, and any technology when you design, in a green building in the HVAC, we make sure that it is integrated with the UV lamp as well as, with the MERV 13. So which are very important aspect in the green building. I think you rightly pointed out already.
See, the COVID is a scenario which is evolving, and nobody has put a actual understanding of the COVID. It is evolving day by day. New things are coming out, new revelations are coming in. It is airborne, it is waterborne. I mean, there is no stop to it, and nobody have a clear thing. But one point which is a general understanding of the public is this virus is spreading through air conditioning, centralized detecting systems, centralized air conditioning. Even though industry has spent a lot of money in putting advertisements, so many things, but there is a general belief that virus is spreading through aircon systems and through centralized air conditioning systems. So maybe like if a user, whether believes it or not, the users are going to demand for a design which can mitigate the risk of spread of the viruses. So what we feel is that we are going to get a more request from the users for more compartmentalized design in terms of air conditioning, more airtight areas, so that the virus will not spread from one end of the office space to other end of the office space. It's a more compartmentalized and individualized air count systems. And second, adding to that, more fresh air systems. So like the panelist has explained, adding fresh air is a cost. Cleaning the air is also an additional cost into that. So what we feel is segregating the aircon and the ventilation systems. You need to introduce a forced ventilation and exhaust system which will take care of the fresh air needs with the proper cleaning and all other activities. And the aircon system will maintain the temperature aspects and the humidity aspects for that. So if you split the system and both systems to work together integrated, together to work in a very seamless way is the going forward in a COVID situation for a public spaces.
Let's talk of public spaces or whichever they are. So if he separates the VRF system into these two parts, because VRF systems very nicely, all companies have what is called the treated fresh air VRF, which supplies cold air, which is well filtered, and that can be filtered to MERV 13, as Mala said, and supplied in a small duct which runs all around, which will take care of fresh air as well as the latent part of the load, which will vary based on occupancy and so on. And of course, the fresh air is taking care of the fresh air requirement. And separately, the VRF system, which is doing the sensible cooling, can run at much higher temperatures just to give body comfort, and the humidity will take care of by the fresh air. So the VRF will be very efficient running at much higher temperatures, and you will get huge energy savings this way. Also the great flexibility. So this is one option. With small museums, small hospitals, all these things can be done in this divide and cool way, and it will be safe. And the last thing is what Gaurav stressed upon is that boxes which are air handling units or small ducted units or even the ducting, that is the biggest cause for the problem inside, because everything gets stuck inside there. So if you have certified boxes which are not leaking, because after filtering the air is going inside the leak of the box. So what is the use of that MERV 13 filter if somewhere else the air is leaking inside, right? So this is most important for that air quality. And of course, with all the other treatments which are active treatments, we can take care of COVID with any system of air conditioning very well. And the public has to be assured step by step of how we are doing it. We have to educate the customer very well. I am seeing now places are putting up outside their place of visit, how they are taking care of you inside. The other thing is cross-contamination between people sitting close together. If you go in a restaurant, you're going to take off your mask. Then how is the protection going to happen to you? You will be having a drink or eating your food, or even the movie theater, you will be eating popcorn. So how are these guys going to get taken care of? It is by very good air movement. So a lot of studies have been done now on how to take the air and take it away without it touching the other guy. Maybe you take it below his seat. So I don't want to go into detail about it, but all these changes have to come to make places safe about air distribution. It's one of the biggest subjects now, air distribution, safe air distribution. And that will be the solution for ducted systems.
How can fabric duct contribute in green building?
It's a good idea to do a fabric ducting, but we really need to see feasibility, because fabric ducting just need to be very close in terms of hanging. We need to see, we can't do that over the false ceiling. That's not possible. It is generally happening in the areas like restaurants or areas where you can have low hanging ducts, and you can just remove them easily, wash and put it back or something. So it is possible solution for some areas, but not for all the areas. But this is one of the solutions which is available today.
Can you get highway tunnel ventilation system certified for sustainable green building? Is there a
Yeah,
project?
actually, as such, the agencies I deal with for green building certification, they don't do the same, but definitely there are international standards and it can be done.
I think today the products are very, very efficient. If we follow the international design, we need to look at one thing. When we are talking about a highway tunnel, it's not just an energy efficient system we are looking at. We are looking at people lives there. The guy who's driving, if he met with an accident, if something happens, then how the system is going to operate. That is more important than saving some energy somewhere, But the good design with the good products inside, which is the latest technology, will definitely help in terms of meeting certain requirements. But there is no international standard today speaking about any highway tunnel specified to any green building rating or something. But yes, you have a LED light which is saving on electricity. You have a PLC control which can control the complete system based on the CO monitoring inside. There is a complete fire alarm system which can open. So you are not consuming a lot of energy there. You're just switching on, switching off based on the demand. So that is easily available today.
Yeah, because when it comes to the product or technology certification program, let me tell you, there is a Green Product Council of IGBC CII, which is certifying such kind of technologies nowadays. And you can get certification for any product or technology which saves energy and which also takes care of your life cycle cost analysis and various other aspects, which improve the quality of environment. So there is a possibility of getting certification in India now. Yeah.
So, yeah, I just have to add to this question. It's one thing to be certified for green. That's certainly a desirable thing. But in the case of tunnel ventilation and tunnel treatment, the most important thing is, as Gaurav said, if there's an accident or if there's a fire. The fire can happen when a car crashes. And so how do we get rid of the smoke and fire, which is a very different aspect altogether. For those, there are standards. For those, there are very good international standards as well as national standards. And the National Building Code also touches upon this thing, not because of tunnel, but because of parking and so on and so forth, we can apply similar guidelines to do it. But your question is to be answered about who is the certifying body for the safety of operation of a tunnel. It will be largely to do with how quickly that fan can exhaust smoke and how it takes care of fire. How do you take care of fire in the tunnel?
There's a question from Mr. Vikas Kondal. That question is for Mr. Vikram Murthy, sir. Would like to know if absorption chiller is already used in any project in India. So if you can just share some reference.
So I have worked with absorption chillers, which are pilot ones, which are small ones, and both of them are in universities. One is in MNIT Jaipur, the other one is in IIT Madras. Because I am doing some research in IIT Madras, I happen to see that over there, working on it. And also my company in Bombay has got an agency for this, and we are trying to get a project which is using waste heat from a glass factory in Gujarat. It is a 500-ton application, but we don't have the order yet. However, the company which is the manufacturer has done quite a few projects. So I've told Vikas that since I don't know the answer about where they have done, I will ask them and reply to him by Monday or Tuesday on an email about where it is done. But it's a thing of the future. Because it costs higher, there's a resistance to buy it. So this will have applications in where waste heat is available, or in the district cooling plants of the future, where you can use solar on-site or off-site to give 36 degrees water and get free 7 degrees cooling water on the other side. So we'll have to wait to see the big projects. But there are some, I will let Vikas know.
I had one specific question related to what is going on now, is that oxygen level is being asked to be monitored by doctors and by hospitals. And very normal that when you go to a hospital and somebody gets admitted to a ward, they put that small meter on your fingertips and they measure the level of oxygen, 90%, 92%. It typically is in the range of 90 plus. Now, doctors are now saying that especially old people at home, their oxygen level needs to be monitored, because if it falls down, then they are more susceptible to the COVID attacks. The question is, all of us, we talked about temperature, we talked about humidity, we talked about carbon dioxide. We didn't touch upon oxygen. Now we know that even in clean places, wherever we go, we are breathing about 16, 17% oxygen. That is known. But we should be ideally breathing 21%. So what are we doing from our HVAC perspective to fix that problem?
Yeah, so I was thinking about this problem and I was writing an answer to Arup. I don't have a very specific answer now. Arup probably has a technology solution. So I have a colleague, friend Gautam Baliga, who is working on this, and he will have the answer. So my simple answer to Arup is, though it's not the right answer, which he's expecting about having higher level of oxygen, because the air is supposed to contain 21% oxygen. All of us know as young students of science that 21% should be oxygen, whereas there's reduced oxygen levels in places which have higher carbon dioxide. So the very simple answer to it is ventilate, 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 and take as much as possible air from outside. So we must know what is the CO2 level of air outside us. So if outside us is 300 parts per million, that is quite good. If outside air has gone up to 600, 700 parts per million, you will never get 21% oxygen inside, because you will breathe more carbon dioxide inside. So the answer is a positive way of introducing oxygen in whichever way you can. So I don't have a proper answer to his question. Maybe he can enlighten us. The only way I know is to do dilution, or you have to add oxygen, which means it's a costly oxygen generator, or you have to have one small can next to your nose like a mask and breathe that oxygen. But that is not the right answer. So Arup, I will prefer that you...
Malaji, you want to add something?
I think being an environmentalist, I would like to add here, we can, add a lot of indoor plants, which can really improve the air quality. And there are specific plants like money plant, aloe vera, and which I know. And I think they could really do wonders to increase the oxygen level. There is an example in Paharpur Business Center in Delhi. One of my colleague, Mr. Kamal Mittal, he has used more than 5,000 plants in his building itself, who made the chiller plant, actually, the company is Paharpur. So I think he is getting tremendous benefits and, to get the oxygen levels and improving the air quality holistically. So I think we could think, various other aspects also sometimes in the life. That is also very important.
I looked at what is being done in Japan and Korea.
Right.
In Japan and Korea, they have oxygen bars where people actually go in and they take in rich oxygen in their air, in the breath. Now the question is, why are they doing that? the value proposition they say is that it's to rejuvenate you. It is to bring energy back into you. So it's like a booster. So the question is that if they are going to take more oxygen as a booster, there must be a reason behind it. So we looked at the correlation between longevity and effect on productivity of having lesser oxygen in what we breathe. And there is a correlation. Now, how statistically accurate that is, that we have to figure out. But there is a correlation between oxygen we breathe and two elements. One is productivity and the second is longevity. There is a clear correlation. We have to find out how we can map it. Second question is, how do we make it affordable, or what is the technology behind it? Now, what does Japan and Korea do? They know that you cannot have an oxygen cylinder because it's expensive. So they use lower cost technologies by using zeolite mixtures, where the zeolite is able to take out the oxygen from the air and pump it into the room to be able to pump more concentrated oxygen into the room.
About 10 years ago, I went to an oxygen bar in Bombay, in Bandra, because they were very nice places to go and I enjoyed the experience. And they were more recreational than anything else, but certainly I felt good after sitting there for an hour and relaxing with little music and all. So oxygen does improve. And Mala's answer is very correct. I've been to the Powerpool Business Center. I quite forgot about it. And that's a good way, natural way to improve oxygen.
How serious, this question is for Mr. Dipu, if you can answer. How serious is software been considered in HVAC systems? He assumes, the person, that they would need to comply with IEC 60730 standard. So, but are they been looked at seriously?
So currently, if you see the HVAC, it's a mix and match of various components and various fits which you do at the site. So individual systems work on its own softwares, and it gives data where a BMS captures and projects it back to the screens where the logics and systems are not written. So IEC 60 is, I don't think it's much taken seriously by the HVAC industry, because it is not taken by one company as it is, because each component manufacturer goes with its own software on controlling the devices.
So I want to tell you, all of you, that the government of India, and ISHRAE is part of that whole thing, is doing a big project on the Internet of Things and intellectual property ownership of all the things which communicate. So in some time there will be a standard where all HVAC or anything which is working in the building will have to follow a protocol of communication. So this is at least 5 years down the line. So when that happens, all these standards will get adopted by the manufacturers and they will all be on one platform. It will be safe, security will be there, and the manufacturer will not be able to talk to the product which he has sold you and get all information out. So these all things will happen in the future, and the government of India is working on that standard, BIS as a standard. Any of you who wants to join that standard committee is most welcome to participate, because it's very exciting what they are doing.
With that, we would like to end today's session. And delegates, hope you have enjoyed today's session of TCBU magazine Futuristic HVAC Technologies for Public Spaces. Before wrapping up today's session, we would like to thank our distinguished panelists, Ms. Mala Singh of PEC Greening India, Mr. Vikram Murthy of Univac Environment Systems, Mr. Gaurav Vasudev of Gaps Engineering Consultancy, and Mr. Dipu Manuel of Mitsubishi Electric India. Thanks to all the delegates and viewers. So that's the end of today's session. I request you to stay tuned for more such sessions. Thank you and goodbye. Jai Hind.